Good day, everyone. My name is Anna Peter. Good day, everyone. My name is Anna Peter with the red number HNDCS/20/013 from the Department of Computer Science, Hussaini Adamu Federal Polytechnic, Kazare, Jigawa State. I'm here to make a presentation on application of artificial neural network in financial forecasting under the supervision of Mr. Matthew Gochukwu. And here is my table of contents, which contains the abstract, introduction, artificial neural network and its model, artificial neural network architecture, advantages and disadvantages of artificial neural network, application of artificial neural network in financial forecasting. I have the conclusion and finally the questions and answers. First, I'll be talking now on my abstracts. Interest in using artificial neural networks for forecasting has led to a tremendous surge in research activities in the past decade. While artificial neural networks provide a great deal of promise, they also embody much uncertainty. It will provide some guidelines and references for the research and implementation. This presentation begins with an introduction to the theory of artificial neural networks. Subsequently, it focuses on the forecast of stock prices and option pricing based on a non-linear artificial neural network model. It proceeded with a presentation of the application of artificial neural network in predicting exchange rates. This presentation then reviewed the theoretical literature on the prediction of banking and financial crises based on artificial neural networks. In general, artificial neural network is a valuable forecast tool in financial economics due to the learning, generalization, and non-linear behavior properties. Finally, it identifies a number of important opportunities for future research on the application of neural networks in financial economics. Now, let's go to the introduction. Some of the background work for the field of artificial neural network occurred in the late 19th and early 20th centuries. This consisted primarily of interdisciplinary work in physics, psychology, and neurophysiology. This early work emphasized general theories of learning, vision, conditioning, etc., and did not include specific mathematical models of neuron operation. These new developments reinvigorated the field of neural networks. During the last 2 decades, great deals of papers have been published and a lot of different types of artificial neural networks were investigated. Neural networks have been applied in diverse fields including aerospace, automotive, banking, defense, electronics, entertainment, financial, insurance, manufacturing, medical, oil and gas, speech, securities, telecommunications, transportation, and even environment. In the ecological area, the artificial neural network model started to be used at the beginning of 1990, but they are no more popular from later 1990s. Artificial neural networks are currently the most widely used machine learning techniques. These neural networks were first developed in the 1970s, but due to recent increases in computing power, they have become extremely popular and they are now found almost everywhere. Neural networks power the intelligent interface that keeps you engaged in every program you use. Now let's look at what is this artificial neural network. First, artificial neural networks are a type of machine learning algorithm that is inspired by the structure and function of the human brain. Artificial neural networks are made up of interconnected nodes, each of which perform a simple mathematical operation. When an artificial neural network is trained on a set of data, it learns to identify patterns and relationships in the data. Once trained, an artificial neural network can be used to make predictions or decisions on new data. Artificial neural networks contain artificial neurons which are called units. These units are arranged in a series of layers that together constitute the whole artificial neural network in a system. A layer can have only a dozen units or millions of units, as this depends on how the complex neural network should be required to learn the hidden patterns in the data set. Commonly, artificial neural network has an input layer and output layer, as well as the hidden layer, which we'll be seeing in our next slide, which is the architecture of the artificial neural networks, which consists of those 3 layers: the input layer, the hidden layers, and the output layer, as shown in this diagram. What is this input layer? The input layer receives input data from the outside world. For example, in an image recognition artificial neural network, the input layer might receive pixel values from an image. Now, the hidden layer. The hidden layer is responsible for processing the input data and learning patterns and relationships. The hidden layer is typically made up of multiple layers of interconnected nodes. Lastly, we'll be looking at the output layer. The output layer produces the output of the artificial neural network. For example, in an image recognition artificial neural network, the output layer might produce a probability distribution over different object classes. Types of artificial neural networks. We have two types of artificial neural networks, which is the feed-forward neural network and the feedback neural network. Firstly, what is this feed-forward neural network? The information flow in feed-forward artificial neural networks is only in one direction. That is, data flows from the input layer to the concealed layer and then to the output layer. There are no feedback loops in feed-forward neural networks. These neural networks are commonly employed in supervised learning for tasks like classification and image recognition. We use them when the data is not in consecutive order. Secondly, we'll be looking at this feedback neural network. The feedback loops are an element of those feedback artificial neural networks. Such neural networks as recurrent neural networks are mostly used for memory retention. These networks are best used in situations where the data is sequential and time dependent. The feedback loops define recurrent neural networks. We'll be talking about the advantages and disadvantages of artificial neural network. But firstly, let's look at the advantages of artificial neural network. One of the advantages of artificial neural network is that attribute value pairs are used to represent problems in artificial neural network. Secondly, the output of artificial neural networks can be discrete valued, real valued, or a vector of multiple real or discrete valued characteristics. While the target function can be discrete valued, real valued, or a vector of numerous real or discrete valued attributes. Thirdly, noise in the training data is not a problem for artificial neural network learning techniques. There may be mistakes in the training samples, but they will not affect the final results. And lastly, it's utilized when a quick assessment of the taught target function is necessary. Now, we'll be talking about the disadvantages of artificial neural networks. One of the disadvantages of artificial neural networks is hardware dependence. As a result, the equipment realization is contingent. And also, as a result of hardware dependence, the construction of artificial neural networks necessitates the use of parallel processors. The second disadvantages of artificial neural networks we'll be looking into is the network's lifetime is unknown. When the network's error on the sample is decreased to a specific amount, the training is complete. And secondly, the value does not produce the best outcomes. Application of artificial neural network in financial forecasting. What is financial forecasting? Financial forecasting is the process of predicting or estimating future stats of an organization. That is how the business will perform in the future based on historical data by analyzing the income statement, position statement, current conditions, past trends of the financial, future, internal and external environments, which is usually undertaken with the objective of preparing and developing a budget and allocating available resources to ensure best possible utilization. Artificial neural networks are used to predict stock prices and other financial trends. This technology is used by banks, hedge functions, and their financial institutions to make better investment decisions. Artificial neural networks have become a popular tool for financial forecasting in recent years. Artificial neural networks are able to learn complex patterns in financial data and make predictions about future trends. This can be useful for a variety of financial tasks, such as predicting stock prices, exchange rates, and other economic indicators. One of the main advantages of artificial neural networks for financial forecasting is that they are able to model nonlinear relationships between variables. This is important because financial data is often nonlinear and unpredictable. Artificial neural networks have been used to forecast a variety of financial variables, including stock prices, exchange rates, and economic indicators. 1. Stock prices. Artificial neural networks have been used to predict stock prices with reasonable accuracy. Some studies have shown that artificial neural networks can outperform traditional forecasting methods such as time series analysis and technical analysis. 2. The exchange rate. Artificial neural networks have also been used to predict exchange rates. This is a challenging task, but artificial neural networks have been shown to be able to make accurate predictions in some cases. 3. The economic indicators. Artificial neural networks have also been used to forecast economic indicators such as GDP growth and inflation. This can be useful for businesses and investors who need to make informed decisions about the future. Now we'll be looking at the components of financial forecasting as seen in this diagram. We have 4 components of financial forecasting, which is the projected income statement, cash budget, the projected balance sheet, and lastly, the projected sources and uses of funds. Firstly, we'll be looking at the projected income statement. The projected income statement is an anticipated income statement that depicts the expected expenses and revenues for the future financial period, that is usually a year. Secondly, the cash budget. The cash budget depicts total cash inflow and outflow expected in the future. Sources of cash inflow include cash sales, collection from accounts receivable, short-term borrowing, long-term debt, cash sales, and equity capital. The reflected surplus or deficit in the cash budget forms the base for investment and financing. Thirdly, the projected balance sheet. This sheet reflects the expected assets, liabilities, and owner's equity at a particular date. To prepare this, inputs like initial balance sheet, capital expenditure, budget, projects, profit plan, investment, and financial plan are required. And lastly, the projected sources and uses of funds. Sources of funds and its uses in the planning period are shown in the statement. The projected income statement, balance sheet, initial balance sheet are the inputs required for its preparation. Projected sources of funds are cash flow from operations, a decrease in fixed assets, an increase in long-term liabilities, and the issuance of share capital. And this brings me to the conclusion of my presentation. In conclusion, artificial neural networks are a powerful tool for financial forecasting. They can be used to forecast a wide range of financial metrics, including stock prices, exchange rates, and credit risks. However, it is important to note that artificial neural networks are complex models and can be difficult to interpret. It is also important to use high-quality data when training artificial neural networks, as the quality of the output will depend on the quality of the inputs. This is to say, artificial neural networks are a promising tool for financial forecasting and have the potential to improve the accuracy of financial forecasts. And this brings me to the end of my presentation. Questions are welcome in the comment section. I'll be expecting your questions. Thank you for listening.